Traveling at the speed of ideas on the Knowledge Transfer Exchange. Brought to you by the Florida Department of Transportation, the Training Development Team, and the State Office of Construction. 605 Swanee Street, Tallahassee, Florida, 850-414-4150. And now, today's guest.
So I was going to talk about civil integrated management today. Here's the FHWA definition, kind of lengthy. CIM is a collection organization and manage accessibility to accurate data and information related to highway facilities. Concept may be used by all affected parties for a wide range of purposes, including planning, environmental, surveying, construction, maintenance, asset management, risk management. So everybody's clear on what CIM is, right? So I think more simply, it's to me, it's like interconnected technology and related processes used to survey, design, construct, as-built, and maintain roadway and bridge projects. The interconnected part's a big thing because we do a lot of data collection in each design and construction and maintenance, and it's not always speaking to each other, and we're not using it, taking it from one area, using it in another. And I think CIM tries to use some technologies that do that. One thing that you see a lot in CIM is LiDAR, which is light distance and ranging. It's basically using lasers to collect survey data, and with some of the technology like land-based LiDAR, and you can use drones to collect the data. And you can end up with an awful lot of data. Here's a little screenshot of when they're flying the drone. Just from the data you collected, you can actually almost like recreate everything that's out there just with this, what's called a point cloud. Looks just about like what's out there, and they can do some other rendering with it. And you eventually get into a 3D model. There's a couple different models. They call them 3D models, 4D models, 5D models, and even ND. They keep taking it up a notch, but the 3D model is basically like a 3D representation of what you've surveyed or what you're going to be building. And now you have it in 3 dimensions as opposed to just plan and profile. The 4D is just adding project scheduling to that. And then 5D is where you add the project cost info. So now you can start tracking what you're doing and how much it's costing and how the schedule goes. And you have this tool, instead of all those things being separate, are now all tied together. There's some screenshots of, I believe this is AutoCAD on the left, and I think it might also be AutoCAD on the right, but just some different shots of some 3D models of some projects. And you can actually start doing some things where you start coloring things in, and you can really look at the project from a 3D sense as opposed to just looking at the plan and profile. And here's the 3D model on the left and the actual project being constructed on the right, aerial view of it. Went out to a design to paver. It was a FHWA workshop, and they had actually taken a 3D model of the work they were going to be doing and made a CNC, computer numerically controlled model of it. They took a big piece of styrofoam and had this machine mill out the whole surface and the roadway they were going to build, which was kind of neat. Like right now you go to a construction trailer and you see all the plan sheets, right, pasted up around the walls, and it'd be kind of neat to you go there and you have a 3D model of the project. Or I was on the I-4 Ultimate, one of the technical teams, and one of the teams brought in a 3D print of the bridge, one of the bridges. So that's kind of neat. You can actually sit there with the crew and go, okay, tonight we're going to do this, and start moving the actual pieces around and doing some pretty neat things with it. And there's the actual project that was, again, out in Oregon. You can take those 3D models and do some things with like driving simulators. This was at Oregon State, where you got in a car and everything that was in your field of view was based on the model. And so they had stuff in the rearview mirrors and on the screens. No matter where you looked, you were driving through the project, and they let you get in the car and drive around, and they can collect data. They're sitting at another computer with all the information on it, and so they can actually look how drivers are responding to things. So if you've got concerns about, or maybe you don't even know, you have concerns about sight distance and other things, you can let people drive through the project. Be kind of neat for like public involvement. People are concerned about this new barrier wall going up or a new turn lane being put in. Well, here, we'll let you drive through the project. Sit there on a laptop. It was funny. They actually let us get in the cars, and the first thing they told us was, okay, occasionally we'll have problems with people who get sick because you're moving around on the screen, but your ears aren't feeling any of the pull of grab, like where you're making a turn and you feel yourself on. So eventually, or sometimes they have people, get motion sickness. And I said, if that happens, just look away from the screen and it'll go away after a while. So I didn't get sick, but driving through it, and I'm about the fourth or fifth person. I'm like, all right, everybody's driving through it nice and normal. I'm like, okay, let's see. I'm doing like 80, 90, 100 miles an hour. And I was waiting to see if I would hit another car and it would move like a video game or something, but it just like all of a sudden it would disappear and you'd go through it, skidding off to the side. They had one for bicycles too, so that you could actually sit on a bicycle and pedal your way through a project. Pretty neat stuff though. There's also e-construction, and I'm sure she's working with a lot of us on different e-construction things, like using mobile devices, looking at e-ticketing, digital signatures, collecting the information and even some of the documents, some of the databases, and actually trying to get more of the data coming in as the electronic data so you can put it right into the database and get away from people filling out paper forms or typing stuff into spreadsheets, that kind of thing. There's a few screenshots from an e-ticketing system called Fleet Watcher that Iowa DOT used for asphalt. And with GPS units and getting information from the plant, they put what are called geozones around the plant and even have another one like right around the scale house at the plant. And so they'll know when the truck gets to the plant, gets loaded out, and they're at the scale house when they leave. And then when they get to the project, they'll have a big geozone when they're near the paver, and then they have another one right when they're at the paver. And so with all that data, you can look at a map and find where the next truck is. You can pull up the information on it, how many tons are there and where it's located. Then they do these different reports, and some of them are more important to the contractor. Like you can look at each of your trucks and see, okay, let's look at the timelines here. Each of these horizontal rows are a timeline for each truck, and you can say, okay, how much time did they spend at the plant for each load? How much time were they at the project? And you can start looking at where, well, everybody's taking 35 minutes to get to the project, 35 to get back, and we got one trucker that's an hour and a half, 2 hours, or those kind of things. And that happens. And on the asphalt side, more than the concrete, you can have second and third party subcontractors being hired, and so they'd love to get paid by the hour and then go park somewhere and not spend money on diesel. And starting to find out a lot of them are already using it for the trucking management, and so we want to add some of the data in from the plant as far as how much they've loaded out and some of the other information that we use in asphalt on the mixed design. Get all that into an e-ticketing system. Along with those individual tickets, you can then have reports on all the information for a project. And it's all electronic forms, so hopefully start reducing some of the forms you have to fill out. The 3D models and all that just allows for a lot more accurate and efficient planning and construction. Like with the driving simulator, you can actually look at how it's going to be driving through, look at things in a 3D view, and hopefully find conflicts beforehand. It's been used for quite a few years in building construction, and you can see models where, okay, we got the air conditioning running right through the plumbing, and that's not going to work. And you can find all that stuff beforehand, as opposed to the air conditioning guys run his stuff, and now the plumber's trying to go through, and it's in the way. I heard of one story where they were doing a project and they had all these antique light poles built in the 1900s or something. They wanted to recreate them. So how do you do that, right? So they did a 3D scan of the thing and could give the shop an exact duplicate 3D model of what they wanted to build. So you get them to make new light poles. You can use the 3D models for machine guidance, and the machine guidance is probably getting used the most right now for earthwork. And typically in earthwork, you're going to pound some stakes in, make some marks, and then guide people on the equipment, especially on a motor grader. They're looking down from their head to where the stakes are, maybe 8-10 feet, trying to eyeball it, and then somebody comes by, surveys it later out. You cut too much, or you didn't cut enough. Make another pass, survey it again, another pass, or finally dial it in. We'll show you some screenshots in a bit on the machine guidance where you'll actually have the model right there, and you can see the blade is where you want to be with the blade as you're going through. This is a shot of just an excavator with some GPS equipment on top of it. And on this, they do some work with the hydraulics to figure out where the end of that bucket is. So they can look on the screen and see where they're digging, do a little bit of work with that. And that's more like using it in a passive sense. So they'll figure out where the bottom of that trench needs to be and dig that out just by looking at the screen and where their bucket is. Really minimize the surveying they have to do. Here, got some total station equipment on this motor grader. That motor grader driver can be looking at the model on the screen. Yeah, right here. Here's kind of a plan view of the roadway, and there's a little shot here of the icon of the motor grader right there. A little close up of that. And so depending on what the driver's trying to construct, in this case, they pulled it off to the side so we could get up and look at the screen, but they can pick a line and say, I want to put the right side of the blade on that line. Now they can watch their blade on that line as they're driving right on the screen. And so if they're cutting a lot, let's say they got to cut 3-4 feet out, you can't just dig that blade in and say, hey, just let it go automatically. So they'll drive by, take out some, and they'll keep watching. Then when they get within about maybe inch or a half inch from where they're supposed to be, then they can put it in full automatic and just let the machine get operated by the model itself, which is kind of neat. And then there's a bunch of different views. They can go in there. You can see already where the driver had pulled off to the side. He's supposed to have this corner lined up right there eventually. And so it's telling him, you got to go to the left. And the right side's got to go down a heck of a lot more. And the left side got to go down a little bit. And there's even numbers, right? 0.36 of a foot got to go down, and 3 feet got to go down. Again, you can't do 3 feet all at once. So he's got to work his way down, but he doesn't have to look out the window for grade stakes and got to go, hey, am I getting close? He knows right away, right where he's at. So then they start getting close and put it in full auto, drive right away, and it's one shot. They're right where they should be. You can even use it for paving. Get that screed right where it's supposed to be. Another shot of some more. And so on the motor grader and some of the other stuff, they're controlling the forward speed always by themselves, and they're controlling on some of it the left and right of the machine, where the blade up and down will get controlled by the model when they're in full automatic. Here on the slip forming, they've got it controlling everything. So the left, right, up and down, it's all getting controlled by the model. And then the driver of this machine is all he's doing is operating the forward speed, and everything else is getting steered by the model. They're putting down some barrier wall right here coming out the back of this slip form machine. A little closer shot of it, or further back shot rather. And so normally if they had to do this in the past, they'd set up string line and they'd have some electronics that rode on that string line. But now you have a string line in the way, and if anybody bumps into it or backs into it, then now you just have the model. Yeah, you think about you're on a construction site, you're worried about not getting run over. You're not looking for this tiny little string that in the middle of the day and the sun's bright, you can't even see it, or at night you can't even see it. Yeah. And then think about a string line might be in the wrong side of things where the truck's got to pull in, so they got to open it up and then put it back. Just saves all of that. There's also stuff called intelligent compaction, and with the GPS unit on the very top there, they can track where the roller's at. And there's software where you can actually look at the number of coverages. So you can look at, like with the asphalt paving, so make sure you get the right number of coverages. There's also some readings they can take. Right now, I don't think that's perfected as far as the stiffness of the soil or stiffness of the asphalt if you're paving, because that's all dependent on temperature of the asphalt and other things. And so you got to collect an awful lot of data to try to correlate whether it's been compacted enough or compacted too much in the case of asphalt. So the machine guidance equipment is pretty much running off either robotic total stations or GPS. And there's kind of advantages to one versus the other as far as what you're going to do. The robotic total station is kind of like line of sight. So you set up every 500 foot or so, you set up a robotic total station piece of equipment, and the machine needs to be able to see it in a line of sight from that unit on top to the robotic total station equipment. And so if a truck pulls in between there, it'll actually give a signal to the driver and the motor grader or whatever that, hey, we're not getting signal anymore. And so depending on what stage they're at, if they're still hogging out material, got to go another 3 foot, they'll just keep going. They'll pick up the signal and when they get line of sight again. If they're actually doing the final finish elevation of that roadway, they'll probably stop, yell at the truck driver, then continue on. The GPS, that one, you're looking for GPS satellites. So if you don't have line of sight to the GPS satellites, you can't use it. So you know, underneath a bridge or in an area where you got a lot of tree cover, might not be as good. So there's some land-based units that you use with GPS, so you can pretty much get to the same level of accuracy. Without that land-based unit with the GPS, the robotic total station is more accurate, but there's ways of improving the accuracy of the GPS. So either one of them can get pretty good accuracy. Then you can also give rovers to the inspection staff, so they can go out and collect data to check did they actually get it to the right elevation, and collect data on the project as far as horizontal distances, and hopefully use those 3D models of what was had before, what they were supposed to build, and what they actually built to figure out construction quantities. That's one thing we want to look at. Just a couple of shots of the rovers being used out in the field. Some details on the GPS and the robotic total station stuff. As far as challenges to implementation, kind of the legal and the spec side of things, you know, we got to write all those specs to try to incorporate that and do business differently. It's a new way to deliver design. Got to make sure all those lines in the CAD files and MicroStation files, everything connects. Like in the past, as long as it looked like it was connected, it was fine. Now, if you're trying to figure out volumes and there's an opening, that program can go nuts and not give you a good answer. The construction side, as far as the inspection, you know, all these inspectors they'll have to know how to use those Rovers, and there's a couple different companies that provide them. And so right now we're doing a lot of like over the shoulder looks at what the contractor has. It's just kind of new territory. So you got all this new technology to learn, change how we're doing business, and sort of the fear of change, fear of failure. You know, have people, you know, why do we got to do that? Well, we've always built it the other way and it's worked fine. So, well, we can improve things and hopefully reduce conflicts and get more accurate quantities. I know overbuild's a big one. I don't want to see some of the overruns go away on that. We don't have enough accurate survey of the existing condition to then say, okay, you need this much overbuild on an asphalt project to bring it back to where the slopes really need to be. And so that gets overrun a lot, and that gets pretty expensive on some jobs. But if you have a 3D model, you got a point every couple millimeters, you can get some real accurate quantities. And then even with the leading and all that, try to provide that 3D model to the contractors. They've got software they can use to do estimating and really figure out how much time it's really going to take on their jobs based on those models, as opposed to looking at the plan sheets and trying to figure out how long it's going to take and where the conflicts are going to be. That's about it.
That's it for now, folks. Until next time, buckle up, travel safe, and always keep moving at the speed of ideas on the Knowledge Transfer Exchange. See you next time. This has been a production of the FDOT Construction Training Development Team, building bridges to the future, one mind at a time.